Yes, I will be talking about everyday indoor environment. Welcome to everyone. I'm associate professor at section for building energy of DTU, but I have spent a lot of nice days and nights at the center. I don't have any pictures. But, why I'm going to talk about everyday indoor environment? That's because we try hard to build energy efficient buildings that provide comfortable indoor environment. We create directives, we write building codes, we make standards and guidelines to make practitioners confident and do their work correctly. We issue building energy passports, we create certification schemes for buildings. We apply a lot of technology in our buildings. We have sophisticated building management systems and so on and so on. But do we actually get excellent indoor environment, and do our buildings provide us and perform as we want them to do? During the last 5 years, I have been involved in investigations of indoor environmental quality, both measurements and questionnaire surveys in about 9 office buildings around Europe and in Denmark. These are mostly modern buildings from medium size up to quite big ones. All built with high energy efficiency in focus, with all different possible HVAC systems, thermoactive systems, for example, like Ongun just presented, and so on and so on. What we did in these buildings, we made long-term measurements of basic indoor environmental quality parameters, satisfaction surveys among occupants, some short-term measurements, and sometimes, when it was possible, also analysis of data from building management systems. If I should briefly summarize the findings from all these different measuring campaigns, I would say these buildings have a tendency for overheating, for being at the warmer part of the range, which is in the standards. For example, EN 15251. It will be called something else soon, probably. So these buildings tend to be on the warm side of this, with morning temperatures 23 degrees in the beginning of spring, and then as the day goes, of course, we end up with quite high temperatures already in the spring. 3 top scoring sources of discomfort according to the occupants: too little air movement, solar irradiation, and draft from ventilation systems. So if I think about these results, what can be the reasons for that? There can be design. For example, absence of external solar shading. Architects don't like external solar shading that much, but I'm not going to talk about design today. What I want to focus on is operation, and there many times we see that our HVAC systems are complicated, control systems are complicated, and in the end, the building operators have it difficult to actually run the building correctly. So that's one thing I want to focus on. And then maybe we should also think about how we actually analyze and evaluate the indoor environment in the buildings. I will start with building operation, and this is a true story. This is when a researcher measures in a building, and he can see that it's becoming quite warm already in April in the afternoon. And he suggests, okay, you have a mechanical cooling in the building, so maybe it should be actually used. And then he talks to building operator, and he says, you know what, I don't think we should use cooling because actually it's a heating season still. So I will try to fix it with, we have some possibility for natural ventilation and so on. What the occupants think about that, and this is really taken from the survey, you can see it yourselves. It gives draft, it gives thermal discomfort, and it certainly distracts people from the work they should do in the building. This story made us to think about a project, and it's a project which is still running. It started like 1 year ago. It's called ENDRIN. The abbreviation is from a Danish name of the project. I will not translate it now. But basically, what we are doing is we are trying to map the skills and competencies and awareness of building operators regarding indoor environmental quality. We do structured interviews, we visit the case study buildings, and so on and so on. If I should mention some first results, and we have done about 15 interviews so far, they are quite thorough, full interviews. We spent some time with the building operators. One important thing I want to stress out is that there is absence of well-defined operational strategy in terms of indoor environmental quality. The building operator should have in his hand. They are simply missing this to guide them through. It's quite often it's difficult for them to distinguish between the IEQ requirements, the ranges of the different parameters we should have in the buildings, and the actual set points they are setting in their building management systems. In connection to that also, about 50 of them are saying that they have been to some course or training about indoor environmental quality, but actually 30% of these trainings were organized internally in their facility management companies and so on. So we actually don't know what was the quality, what was the curriculum in these courses or trainings. On the contrary, almost 80% have been to some training regarding building management systems. So it seems that there is a lot of focus on how to control, but there's a little bit less focus on what we are actually controlling for, which is the indoor environmental quality, of course. The next example is analysis and evaluation of the results. When we want to categorize the buildings, we have this well-known categories according to EN 15251. And in this analysis, we were looking at measurement uncertainty when we do field measurements of operative temperature, and how does this actually influence the category in which the comfort category in which the building would be classified in. What we used is we took 4 buildings, we took about 1 year measurements in 2 spaces, south and north, and this is the current practice. So we draw basically a line, and then we say if we are below the line, we are within the category for this part of the occupied time. If we are above, then we are out of the category. What we try to do is try to take expanded standard uncertainty, a classical ISO guide for uncertainty of measurements, and just do this analysis on the temperature data and try to account for the measurement uncertainty when we do the classification. What the results show, in general, when we take all our buildings sample together, this expanded standard uncertainty is about 1.3 degree. So it's plus minus 1.3 degree on the mean, on the hourly mean temperature, which is in itself, it's quite something. And then it of course tremendously influences the categorization. So these are 4 buildings, 2 spaces in each, and then you can see that if we apply a current practice, we have a time about this 5% occupant time how to say, border defined by the EN 15251. If we include the measurement uncertainties, actually all of the buildings would fulfill the requirements. So that's again just to consider how we are measuring and how we are evaluating. And then the last example, it's again ongoing project. It's also actually almost voluntary because it's unfunded. Nice that not only me, not only I'm involved in such a project. We are trying to look at how to relate energy consumption in the building and indoor environmental quality. Because if we look at energy management, there is a lot of K figures you can use, or the building operator can use to judge the energy consumption, how is it going, and so on. But if you talk about indoor environmental quality, it's usually more like scientific time series analysis of the different parameters and so on. And this is something which building operator is not able to do in his small room somewhere in the basement. So what we try to do is that we try to take data from 5 buildings, aggregated energy consumption and discomfort, again, according to the standard I've already mentioned. And what we do, we simply graphically plot the percentage of time outside the chosen category monthly and the aggregated energy consumption. There is a lot of analysis behind that, how you get to monthly temperatures when you get a lot of rooms in the building and so on. I will not go into details, but what we can see is that you can compare the buildings among each other, which is maybe interesting for owner of all the buildings, but you can also see how it develops for each building separately. So the building operator can say, okay, my consumption is actually increasing during summer months, but I'm still having bad indoor environmental quality. So there's an indication there that something is wrong. Okay, I will just wrap up. So it's not only design, it's also everyday indoor environment, which is important. Buildings usually collect data about themselves. We just have to have a look at them. And we should not forget people who operate the buildings, because they are a link between the technology we have in the building and the occupants who actually use the building. Thank you very much.